The presenter is Virgilijus Krinickij. He is lecturer and researcher at the Faculty of Mathematics and Informatics in Vilnius University, and at the same time member of the Cybersecurity Laboratory in Vilnius University. And he will talk, topic of his presentation is Web Application Vulnerabilities, Broken Access Control. Please, Virgilijus, start.
Yeah, hello. So let me share my slides. So I hope you can see them. Now, first of all, as mentioned before, I would like to talk a little bit about me as presenter represented. I'm a lecturer, researcher, member of Cybersecurity Laboratory in Vilnius University, Faculty of Mathematics and Informatics. If you would like to know a little bit more about our cyber laboratory, here is a link for you to check upon. And if you have any additional questions, you can also contact me via the email provided for you. Yeah, so a little bit the content of this presentation. I'll talk a little bit about web applications, about the security report in 2021, about CMSs in government institutions frameworks, a little bit of the analysis in our country, and of course the newest OWASP top 10, and the newest OWASP top 10 #1 risk, broken access control. So. As you know, web application security is the most significant battleground today, especially during the pandemic. Most of us had to change our view on how to buy things through internet, basically, and not physically. So small businesses had a huge uptake in bandwidth and sell of goods, and it's will be still a battleground for the foreseeable future, because, as mentioned before, we have huge threat profiles that are coming up, and kill chain is becoming increasingly bigger because, again, the pandemic changed our view on perspective of security. But again, from web application perspective, what to choose and what we can use. So basically, we have frameworks, we have CMSs, we have static responsive designs that people can use just for their own personal representation of portfolio, for example, and everything else. The most vulnerable applications today is still CMSs, and small businesses use them for their e-commerce and to sell goods, and of course to bring as much information as possible to the surrounding environment. Now, you don't need, as you know, you don't need to have additional CMS skill. You don't need to have additional information technology skills to configure your CMS, and ordinary people can do that. But of course, some amount of skill may be needed to put the files in the FTP server and connect it to the database. But other than that, the install process is the same as installing some program in your operating system. It's like click next, put some additional information, and you will be good to go. Now, everything depends on the scope. As you know, everything depends on the scope of the organization, of the people that want to represent what they want to present. So basically, if you are an organization, maybe a monolithic CMS approach would be an old-fashioned approach. Maybe you would like to take a coupled or headless CMS approach. Maybe if you're just a simple person, you would like to have a representational website without any CMS or frameworks, right? You just probably would take some static design and put it in the FTP server, and that would be it, and that would be sufficient enough. That way, you would lose all the significant attack vectors like SQL injections and connections to your backend, because you wouldn't have your backend. You wouldn't have any kind of backend. You would use your FTP server or some more functional IDE to lively change your code. And that would be it. So at this point, a framework or CMS would be an overkill for your web at this point. And yeah, depending on what you want, what your scope is, if you're a huge organization or if you're a simple person that wants to represent his information on the web for, I don't know, for example, going for a job interview, and people would like to see your portfolio, for example, if you have some additional IT skills on the web, you probably could minimize your security issues doing it this way. Of course, all the other use cases stand as follows. Now, web application security in 2021. So if you know, back last year, Krinickij has provided an incident report about all the web application vulnerabilities. They did a scan from their own customers and other online users, basically by using their tools, and scanned the entire network as much as they could reach, and they gave a summary of things that they found. So by global location, they scanned all the places that they could reach: the Europe, the Africa, the North and Central America. And the biggest problem that they found was that the CMS had the biggest CMS, WordPress, at this point had the biggest amount of vulnerabilities targeted for the users that used these CMS. Of course, other medium and low type application vulnerabilities also were present. So of course, XSS is the most common one. 27% were in high severity. 63% out of those were in medium. 10% were low, and out of 126 was WordPress, and 25 from 100 was especially the XSS part of vulnerabilities. But of course, still, if you choose one of the most top 3 common CMSs for your web application, then it would be or WordPress, Joomla, or Drupal. And related issues, as you know, mostly come from the top 1 from those 3. So in 2019 and 20, we had a lot of problems with WordPress. Now it's the same actually in 2021 and 2022. The amount of vulnerabilities presented for this particular CMS does not change. Of course, others also have vulnerabilities, but they are significantly lower in percentage. And as you can see, Drupal is the most smallest. It has the most smallest percentage in the vulnerability count for last year. Now, so additional, just a small representation of data that was accumulated back in the 2018-19 research, so that top 3 CMSs that were used, of course, was WordPress and Joomla Drupal. And at this point, Magento is an e-commerce CMS that also is provided for, could be used for standard information providence, but it's an e-commerce platform. And recently, like a couple of days ago, Magento had a zero-day disclosure with the CVSS of 9.8 out of 10. And it got a in bad input problem, and the disclosed information says that you need to patch the system as fast as possible. Also, it got a CVA code, and I'll show it in the later slides. Now, what's the biggest problem for using CMS? 98% of WordPress vulnerabilities are due to plugins, third-party plugins, and not only plugins, but the core itself of the most common installation of CMS is the problem. Because even if it's open source, even if we have all the necessary tools to probably mitigate or remediate the problem, it's still the people that use it, because as you know, most of these CMSs, especially WordPress, has the ability to be used without any additional IT knowledge. And this does not change, and this will not change in the foreseeable future if people will not have additional security awareness, if they will not design their project, let's say, properly, and they will not have threat models for their design and so on. Well, we will have the same problem as we are having now. People will still have a lot of vulnerable content management systems. Now, like I said, depending on the scope, what you are doing or you are trying to do, you have to choose whatever is best for you. For example, if you're creating a custom web application that would be used, for example, for accounting or some additional very high-end functionality from SaaS perspective, software as a service, then maybe you would use frameworks, for example, Laravel or Symfony or something like that, because they have much less problems. Of course, they also have vulnerabilities, but comparing to the CMS perspective, they don't have that much problems. And now, again, you need some additional IT skills to use them in your environment, but it depends on what you need. So even if you don't have IT knowledge, but you have money, probably you could buy some third party. You could buy some third party vendor that would additionally give you the capability of using a framework on your some custom, for example, functionality that you need, or reverse engineer the e-commerce system and put it on the frameworks platform. But again, it needs to be researched more, and who wants to take what approach depends on those people. CMSs in governmental institutions, well, if you have ever went to NASA's page, you would have seen that NASA uses Drupal, and Drupal from those three most used CMSs has the least amount of vulnerabilities present. Of course, Drupal in NASA.gov it's not only used in NASA.gov. It has a lot of different NASA-related domains. It has subdomains, and most of them are used by using headless Drupal installation on AVS. Of course, headless installations and coupled installations do have their own problems. Again, resources and time constraints, and managing the presentation layer, and so on. But in the end, it looks the way it looks. Governmental institutions benefit from taking on the content management systems, and it looks good, because they have the resources, because they have the amount of time and money to do this. A little bit about our country's web application security provided by the NCSC. So in 2018-19, we had 220,000 websites scanned in our LT domain, and 52,033, basically 52% of LT websites with CMS were identified and are vulnerable and could be hacked. Of course, top 3 CMSs do not change in this time. In 2020, after analysis of active Lithuanian domains, NCSC managed to identify 70,000 websites, 38% of all active, and 65% were not updated. 6.5% were not updated, or not generally supported even. So again, it doesn't matter if we're in the world or we are here in Lithuania. We have problems with these web applications and third-party plugins that give the benefit of functionality, but from the security standpoint, what we can achieve is probably better security awareness and better design of your system. For example, our Vilnius.lt uses WordPress. Again, if it is safe or if it's not safe, it's a different question. We need to analyze the situation, but governmental institutions use this. And back in the day, we had problems where some websites were hacked and some injected information was posted, and that was not good for the representation, for the people that presented that information, basically the representation of their institution and so on. But it's still used today, and that is okay. But why the organization chooses the CMS? It's a proven development model. As you know, CMSs historically go way back, back to the 90s and then the 80s, to the end of the 80s. After that came frameworks, and now we have a mix of a lot of technologies, and we do realize everything depending on what we want. Open source code base and large contributor community, that is a stick with two ends. At one point, we can look at it as a bigger community, a bigger influence on functionality, security, good speed, so to speak, of the system. But at the same time, the statistic shows that it's the opposite, and a lot of problems still arise based on third party, some additional software that could be added to the system, or the core performance of the system. Dramatic cost and savings, scalability, some amount of security, of course. Because when we separate the presentation layer while using, for example, headless CMS approach, we minimize the monolithical approach where everything is in one point. It's harder to depict where is the presentation layer, where is the other parts of your system, and so forth. But again, like I said, it's a problem from both sides. And role-based permissioning and workflow for tired content management. And yes and no. That's why last year's top 10 has broken access control as #1 in its OWASP's top 10 list. Basically, user levels became biggest problem again because of the pandemic, because of the rising security issues and the threat profiles that were mentioned before, that they become very sophisticated, and this was the biggest topic in the past couple of years. So like I mentioned, users can submit arbitrary input, and the newest Magento 0-day RCE with the provided CVE of and proper input validation gives the CVSS of 9.8 from 10. But still, it's one of the problems that arises. Other problems is underdeveloped security awareness, and for small businesses, especially that use WordPress, for example, we see that in my experience and other people's experience, we see that you don't need additional IT skills, and people mostly don't think about security unless something happens to them, unless something, it doesn't matter if it's physically or from cyber domain. When something bad happens, then after that, some security awareness comes into play. Custom development, again, even if you provide your system, then you add, for example, some custom development of your own to that system. And if you don't know how that system works, additionally, you may be creating some attack vectors, which could break your system at some point if you don't know what you're doing. Deceptive simplicity of that, again, custom development, if you are not using it the right way, you're not using the right paradigms, and if you don't apply the work smarter, not harder approach here, then your simplicity on custom development and zero security awareness, if we're talking recursively, will bring some problems to your environment. Rapidly evolving threat profile is also a problem, as mentioned, and I'm repeating myself. But threat profiles and sophisticated attacks with evolving cyber kill chains is wow. It's very very huge, and from website perspective, it's also today a common thing, because again, because of the pandemic, we had to switch to web, but most common types of attacks come without saving the CMSs that were used before. For example, they were not updated, and those attack vectors are very easy. And then after adding some additional security measures, that profile became also increasing. Resource and time constraints, again, depending on your scope, our extended technologies, front-end and back-end. So depending on what you use, if you use a framework for your representational website and you just want to learn how to use it, that's fine. But it comes with a lot of additional modules and capabilities that you don't need unless you're building a very sophisticated custom development system. And of course, the increasing demand and functionality, closed source and open source. For both, it's good to have functionality, but if you add functionality without, again, recursively looking, without any security awareness, or you do it on top of what is created by only without knowing the system with your own hands, and you do it with deceptive simplicity, then what's the point? So for both open and closed sourced CMSs, it's the same. Yeah, so the majority problem involving is the design and the design of your system. If you well, here we go to software engineering perspective of methodologies and everything else that goes with it. Web applications are not a part of software engineering, but we can use software engineering development methodologies and everything else that comes with it, basically the mindset, and we can incorporate it in web applications, and of course adding security measures like threat modeling and boundary conditions, canonicalization of your input, and so on and so forth. We could make the system better. We could make that, well, web application better. And because of that, we have the newest OWASP top 10 number 4 spot, which is in secure design. So as you know, OWASP top 10 comes out every 3-4 years. It's the 7th update. It gives the most, it gives the top 10 risks and likelihoods. It gives the top 10 risks, not the likelihoods or vulnerabilities. And the new spot, number 4 spot into 2021 is insecure design. So as I mentioned before, this goes in the scope of software engineering, and it could be a number 1 spot probably, but well, we have what we have. Additionally, we have new categories like software and data integrity failures, server side request forgery, which is well, something to discuss maybe in the future, but others from the 2017 were connected to minimize the not the scope, but the representation of what the top 10 OWASP wants to give to you. So basically connecting similar things and naming it with a significant abstraction would give the proper way of representing it today. Of course, number 1 is broken access control. It jumped from number 5 spot, and I'll briefly talk about it. But of course, number 2 is cryptographic failures, which will be discussed later on today. Injections is still a very, very common thing, and if it's an arbitrary input from the form of the URL or whatever, and it could be injected into your database or backend, or just reflected as a reflected access to your screen. It's still an injection that could be used, but it's something that went down compared to 4 years ago. Yeah, the number 1 thing, broken access control, we'll talk about user levels. So user levels are the most needed thing, and was needed thing very, very, very much back in the day, and especially today. We can segregate who is where, right? We can depict who is a simple user, who is an admin, who is whatever. But if we break that access, we typically could disclose information or modify that information, and so on and so forth. And that is bad. So all of this information is also accessible in the OWASP top 10. So you can use that. You can break the access control from the URL part, or by leaking the information in the HTTP, for example, if it's some kind of a hash that you use, or some additional functionality could be broken to for you to add yourself to the admin privilege and so on and so forth. How can you prevent it? So basically, access control is only effective in the trusted server side, or if it's a serverless API. So disabling web server dictionary listing, ensuring that the file metadata, well, Git and backup files are not presented within the web roots. And it's a very common mistake to have your Git in your web server root, and that's well, how you can get to some additional step in the final attack vectors path. Of course, logging access control failures, alerting admins when appropriate. Repeated failures also is a good idea, but sometime if you, for example, if you break the ACLs, or you leak that information in the HTML code, for example, you can modify the URL in the backend, for example, or the front end, and by using that token. And well, what's the difference between logging and that attempt to break in or not? So that's an additional attack vector from those perspectives. Yeah, limit API controller access from automated attack toolings. If you're using that comes again from custom CMSs and custom development if you need it, or from third-party vendors that provide it, if they have additionally added these security measures in the system. If not, then probably you need to think about preventing this possibility. One of the examples I wanted to present here, there is, for example, a plugin that enables logging of bad URLs in the web application. And for example, if an attacker could create a malicious link, and here he uses a hippoglyph, whatever IP it could be, it's a WordPress installation, but if he uses a hippoglyph to access the admin page, he knows that an A character is not an ASCII character, but a Cyrillic A character, which can be encoded differently, and he can inject that link into the system. The system functions use it, and they lack the capability to check and rely on the same security nonce. The nonce in WordPress is a token that is used for CRUD operations, and it lacks the capability to check and rely on these things. That's why an attacker could use a hippoglyph to create this link. So the nonce is leaked in the backend, and basically you can use to craft these types of links. Of course, depending on the scenario, you still need to be connected to the backend for these requests to go in and out. These requests go through the AJAX. And of course, WordPress has its own methodology on what functions to use and so on and so forth. But it's if the information is leaked, then the capability of this functionality provided by the vendor it is mute at this point. So here is a more common example. When from the backend, if you use the link with the hippoglyph, you can customize, for example, that link and you redirect it to the attacker's machine. At the same time, it could be as a MITM or MITM, man-in-the-middle attack, where a user uses the customer's machine and the vendor's machine, and the customer is redirected. But again, the client needs to click on that link specifically, and then he would be redirected to the same WordPress installation, but already in the attacker's machine. Yeah, so additionally, what we need to do, open source doesn't have methodologies on how to prevent it. OWASP has its own technical view on how to do it, but for people who don't have IT skills and security awareness, and they add some additional functionality and everything else, there is a CVD, Coordinated Vulnerability Disclosure for open source projects. Google presented their own on how to fix, and OpenSSF project created their own methodology based on this subject, and it's for cyber researchers and so on and so forth. So Google also sponsors it. So this is one of the possible steps on how security awareness for web applications, especially CMSs, could be provided. Like I mentioned, the lack of security design and security awareness will not change for the most popular CMSs, and the security flaws will still be in the future. If you're a simple person, you have IT skills, you can create a small representational website. You could use a static index file, for example, and that would be it. You would minimize the attack vectors significantly. Of course, the only problem would be the hosting provider and their side of security aspects. Yeah, a little bit of references and questions.